Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about the reaction of acetone. You can see the reaction and you have to say what is the major product of this reaction. And 4 options are provided here and one of them is the right answer. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. Don't hesitate whether your answer will be right or wrong, because self-evaluation is essential for improvement and that's why you should try. I believe you have tried by yourself, so it's my turn to give you the right answer. Now in this context student, reactant molecule is pretty simple, but there are 3 separate conditions. So that's why I suggest you please look at the first condition. Magnesium amalgam in dry ether and H3O plus. So can you understand what reagent it is or what type of reaction this is indicating? Yes, this is actually a pinacol formation reaction. So this reaction happens by, first this magnesium is acting as a reducing agent and it releases 2 electrons, means step by step. So first electron when goes to this acetone, it produces a radical anion. So if one electron is taken by the pi star of this carbon double, it produces this anion and this is the radical. So and remember here magnesium atom is there, so it can coordinate with this 2 anion. Okay, so in this way this radical comes together and that's why this 2 radical combines in this way and ultimately it produces a very unique molecule after workup. So first is radical coupling to produce the, so this is O minus, obviously it's attached to the magnesium 2 plus, better to say, fine, and later on upon workup it produces pinacol. I have already discussed a dedicated lecture on this, you may visit for better understanding. And second part is HBr distill. Generally when we study pinacol, then the same thing named as pinacolone rearrangement, and that produces for acetone this ketone derivative, tertiary butyl, this one side is methyl ketone. But in this case I never used HBr, never used the sulfuric acid. I have used here HBr and distillation, and here product is also different because 4 options are completely different, none of them resembles to pinacol. So from these you can understand the reaction follows different pathway here because of use of HBr. So let's learn what. So in the first step, as I told, how this reaction happen, it produces these magnesium coordinated thing, and after workup it produces these 1,2-diol, or its name is pinacol. Now this pinacol later on react with HBr to produce, it reacts with this HBr and ultimately it produces the diene. Question, how it reacts? We know HBr is a pretty strong acid and it produces H plus and Br minus, fine. So first step of the reaction is protonation on OH and produce this protonated species. Later on what happens, these OH leaves as it's a neutral leaving group, so it's a good leaving group and ultimately it produces these tertiary cation. Okay, now here the reaction method is different. Actually I don't know exactly the mechanism, this is based on my understanding. If you have relatively better explanation, please share with reference in the comment box. So this is the hydrogen. So in this case this Br minus means, based on my understanding, abstract this proton. Okay, and in this way elimination happens. So in the first step what it produces, so this side is as it is, this side, this is the first product. Now these also reacted with this acid means HBr and produces the final diene, but in this case the elimination, so first step is protonation and second step is elimination, but the second step is highly favored because the produced carbocation here is allylic one and tertiary both, and we know that allylic carbocations are highly stabilized because of resonance and tertiary is highly stabilized by this hyperconjugation, fine. So this is a relatively stable carbocation, so similar reason this one hydrogen from here is abstracted and it produces this diene. Now question, why I have written in transdiene? I could have been written in cisdiene. Remember student, in case of cisdiene there is a significant repulsion between these two groups, and if it is in trans the dipole moment is also 0, so more stable, so that's why it is better to mention transdiene. Now question may come in your mind that why pinacol rearrangement did not occur here. Exact reason I don't know, but I believe the basicity of bromide is expected to be higher, that's why it prefers the elimination. And second thing, it is a very high temperature distillation condition, so based on these two it resulted in this diene. So what are the name reaction associated in this process? First step is pinacol preparation. So first step is pinacol coupling, second step workup, and the last step is acid catalyzed elimination or dehydration of alcohol to corresponding alkene, and since it is here dialcohol, so it produces 1,3-diene. So this is the product. So you can see here the option C is the right answer. But a question that if you don't know the rule of last step, how can you come to the right answer? See, magnesium amalgam in dry ether water, this is a pinacol formation. That's true. So in this context, I suggest you student just write your product. This is pinacol. Fine. So can this pinacol react with HBr and produce option A or B? No, it's actually 3 plus 3 C6, 6 carbon species, so it cannot form this 3 carbon thing, so these two options gone. Now option D and C. In option D there is actually 5 carbon, and here carbon elimination, CC bond breaking under HBr distillation, student, not possible, illogical choice. So what option left? Obviously option C, and this is actually the right answer. Now many of you will say that, sir, how can I know every condition? It's true that it is not possible to know every reaction or every reaction condition, but you can develop a common sense, and based on this common sense you can see this C is the actual answer and those other options are dummy. And that's why I always suggest student, please study more and do more practice, and teachers intention is not to make your life difficult, but you have to catch the nerve of the question, then only you can solve it very fast in the exam hall. Okay, so in conclusion, and what we have learned today, that magnesium 2 is actually an alkaline earth metal, and it's actually reducing in nature because it's preferred to release 2 electrons to achieve the nearest noble gas configuration, so it's reducing agent. Now upon 1 electron reduction of ketone, this resulted in radical anion which undergo radical coupling to produce 1,2-diol or pinacol derivative, and this pinacol can undergo acid catalyzed dehydration, and if this dehydration means refluxing condition done in presence of HBr, it resulted in butadiene. Now another next point is, during this acid catalyzed dehydration the first step is relatively difficult as it produces an isolated alkene. Means first step is protonation, then elimination of water, then elimination of H plus to produce the alkene. But the second step means next, because it's a repetition of the same step after, but the second step is pretty easier due to the alcohol is now allyl alcohol and allyl carbocations are resonance stabilized. And finally the distillation results in relatively more pure product in this reaction, because if you look at the reaction mixture, there is diol, there is allyl alcohol, these two reactants are pretty high boiling because of hydrogen bonding, but this diene boiling point is expected to be less, so it could be distilled and pure product you will collect. So this is the end of discussion. I believe this video will be useful. Please write your opinion in the comment box, and if you really consider the content of this channel is worthy, then please help this channel to grow. And I thank you everyone for watching this video. Stay happy, stay blessed. See you in